Welcome at the Future Factory. This is where the magic happens. I'm Wouter Grote-Veldman, team manager of this year's Green Team. The past few months the technical team has been very busy with designing new components and entirely new systems. In this video we'd like to take you on our journey of the design process. So, let's go! The future of Green Team Twente is changing. We cannot push the boundaries as hard as we want to in the current competition. That's why we'll be joining another competition this year. But more on that later. Let's first go to Vincent to find out what changes we've made to the Shell Eco Marathon car.
There are a few things we want to improve on the SAM car. One of them has to do with the motor controller. We want to improve the calibration of the motors on the motor controller to optimize the efficiency of the car even more. Then there's another thing we want to optimize. We want to change the layout of the car. We want to change around the components in order to find a better layout for the center of mass and to reduce vibrations in the car. Once that is done, we want to do more cable management, make the cable shorter, less weight in the car. Then there's another thing we want to improve on the car. That has to do with the data sent to the driver. We're already sending data to the driver through this screen, but we want to improve this data so the driver can make better informed decisions. There are a few things we want to improve regarding the strategy. We want to improve certain parameters in the strategy model and also implement all these parameters into the new Shell Eco Marathon track. Next to that, we want to improve the communication strategy towards the driver so the driver can make the best decision possible in the car. We also want to make some improvements on the mechanical parts of the car. One of them are the brake discs. We want to improve the brake discs to be a better fit for the car. Then we have the wheels. We want to make custom wheels that have more grip, are more lightweight and are a better fit for the endurance race. Then we have the wheel fenders. We want to remake these wheel fenders to be more lightweight and better fitting on the car. We also want to make the handbrake lightweight and reliable working. Then we have the steering wheel system. We want to make it sturdier so it can function under heavier circumstances. Then we're back at the steering wheel. We want to improve the button layout on the steering wheel and make an extra button for speed and torque control. This is a different control mode for the car by focusing either on speed or on the torque of the car. This year is a very special year for Green Team Twente. We are in change, a change of direction. Not only will we continue working on our very efficient hydrogen car, we have also found another, bigger and faster challenge. With the knowledge of hydrogen and efficiency, we will build a car which will participate in a new exciting competition.
After 10 years, Green Team Twente will participate in the Formula Student Race with the only hydrogen-powered car. Formula Student is an international racing competition with events all over the world. Besides designing a fast car, the teams are judged on marketing strategy, construction, and batch production plan. The competition has 3 different classes: the combustion class, the driverless class, and the largest of them all, the electric vehicle class. Green Team Twente will participate in both Germany and the Netherlands. By building and driving the only current Formula student car, they are ready to face the challenge and will deliver an important message. Hydrogen can be a serious alternative to battery vehicles.
The design process of our first car this year is extra challenging, since we have to design and develop a completely new car in just 1 year. Luckily, we have a team full of motivated and talented young engineers ready to push the boundaries of the current racing world. This is an important decision with a big impact. Formula Student is a high-speed racing competition, where technology is pushed to the limits in order to achieve the highest possible result. Endurance is one of the most important aspects of the new race. By participating, we are maximizing our contribution to the development of the fuel of the future. Together with years of knowledge on project management and engineering experience from Green Team Twente, we are sure that participating in this competition will change the racing world. We are ready.
In the coming months, we will show more of our design and car. Green Team Twente is ready to go faster. Can you keep up?
I'm glad that we could finally announce that we're going to participate in the Formula Student competition. We've been secretly working on this car for the past few months and I can't wait to show you our design. We are ready. Let's go back to the technical teams and have a chat about the new Formula student car.
Now that you got a first sight at our car, we're going to look at it in a bit more detail. At its surface, we can see the new car's body. We can see the shape of a real race car. This is in no way similar to our previous cars. The last couple of months, our simulation and strategy sub-team worked on this design for the bodywork. We decided to go for a rather functional design this year. The body functions mainly as a cover for the chassis and to protect the car's components from the elements. And of course, we also want it to be a bit aesthetically pleasing. Only our future designs will be focused on being more aerodynamic. So, the bodywork consists of a few parts. First off, we have the nose cone, which covers most of the front of the car. And this front side also covers the impact attenuator, which is required to absorb the impact of a collision. Then at the bottom of the car we have the undertray. In future designs, the undertray will play a large role in the aerodynamics of the car. The side of a car hosts several different components, and these all need to be shielded from the elements by this large panel of bodywork. Also, we can see some kind of large hole in the sides of the bodywork. This so-called duct provides air to the radiator, and it's shaped in such a way that the air is accelerated behind the radiator, improving its efficiency. And we'll later come back to the radiator and its cooling system.
The powertrain subteam is responsible for the main power line in the car. This includes the generation of the electricity out of hydrogen and what is done with this electricity. This all begins at a hydrogen tank. Hydrogen is stored in a tank with a maximum pressure of 300 bar. The high pressure allows the tank to hold more fuel than when stored at atmospheric pressure. These pressures, however, are too high to flow through the system. That is why the pressure regulator is needed. Before the hydrogen flows into the system, it flows through the pressure regulator. The pressure regulator lowers the pressure of 300 bar to just 2.5 bar. Now the hydrogen can flow at a safe pressure through the supply valve. The supply valve closes to block the hydrogen flow through the system in case of an emergency. This ensures the safety of the driver and the people around the car. Once the hydrogen passes the supply valve, it moves on to the fuel cell stack. In the fuel cell, the hydrogen will react with oxygen in the air to form H2O. The power that can be generated with one fuel cell is, however, too low to power a car. That is why multiple fuel cells are needed. This is called a fuel cell stack. The fuel cell stack consists of multiple fuel cells with a maximum combined power of 49 kilowatts. Next to the hydrogen, the oxygen also needs to make its way into the fuel cell. That is where the following components are for, starting with the air filter. The air filter makes sure no harmful particles can enter the fuel cell's membranes. This is done by filtering these particles out before the air enters the system. The component right after the air filter is the compressor. The compressor compresses the air to a slightly higher pressure of 2.5 bar and a way higher flow rate of 3000 normal liters per minute. This is to make sure enough oxygen reaches the fuel cell stack. The last component in the airflow is the humidifier. Air going into the fuel cell stack needs to hold a certain degree of humidification to prevent the membranes in the fuel cell stack from drying out. This is exactly what the humidifier does. After the air passes the humidifier, the air is ready to go into the fuel cell stack. Now the hydrogen path and the oxygen path to the fuel cell stack are clear, we can look at what happens with the generated electricity. The produced electricity will eventually drive the motors, but needs to fit their requirements and therefore goes through a DC-DC, where the voltage output of the fuel cell stack will be boosted to a more efficient 400 volts, after which the electricity will be stored in the capacitor stack. Here the power generated from the fuel cell is temporarily stored in order to not damage the fuel cell stack for peaks in power output. Additionally, the cap stack gives the opportunity to give a boosted power output to the motors for a few seconds. This can be handy for accelerating. The capacitor stack can also store the power generated from regenerative braking. Before the electricity moves to the motors, it needs to be converted to AC current. This happens in the motor controller. Together with the calibration of the motors, the motor controller also enables torque vectoring and regenerative braking for the best vehicle performance whilst being as efficient as possible. In the motors, the electric energy is converted to kinetic energy that makes the car move with a maximum of 0.5 g acceleration, which means 0 to 100 km an hour in less than 6 seconds, and a torque vectoring that allows a maximum of 1.5 g cornering speeds.
Powertrain makes the energy flow through our car, but we, the electronic sub-team, make sure that the powertrain and the whole car stays safe.
Let us take a look at two parts designed by our electrical engineers, which showcase our focus on vehicle safety. The most critical part of vehicle safety is the shutdown circuit. It ensures that no high voltage is present if the car is in a critical state, as in a crash for example. This low voltage circuit contains 12 critical sensors and components like a hydrogen and a crash sensor that can disable the high voltage connection if they detect any critical values. The shutdown circuit powers the relays of the high voltage system, which always default to an unconnected state if they are not powered. Therefore, any component in the shutdown circuit has the ability to switch off the high voltage system by cutting the connection of the shutdown circuit they are connected to. The tractive system active light, or T-cell for short, indicates the current state of the car. This state can either be there is a high voltage present in the car, keep clear, or there is no high voltage present in the car. This system is based on the regulations of Formula Student, which requires a fully analog circuit for the measurement of the high voltage system state and control of the indicator light. Therefore, no microcontrollers that run software are allowed. The circuit takes measurements from multiple points in the system and signals the safe state with a green light, only if the main relays of the high voltage line are disconnected. If there is a voltage of more than 60 volts at the inverter, the red and therefore dangerous state is signaled. Next to that, the circuit is able to detect an implausibility of the measured signals, for example if the main relays are connected but no voltage is measured at the inverter. This implies that something must be broken with either the measurement or the system itself. Then the T-cells show no light to signal an implausible state. The actual light is mounted in the hoop of the car, on eye level of bystanders, to be easily visible from all directions. It contains 6 bright, multicolored LEDs. Their high level of brightness allows good visibility of the signal even in bright sunlight. A smaller version with only a single LED is mounted in the cockpit, such that the driver is able to see the T-cell status as well.
Another goal of the simulation and strategy sub-team is making a liquid cooling system for the car. And this work starts by identifying which components need liquid cooling. And it turned out these are quite a few. From the fuel cell to the DC-DC, the motors and the motor controller, and finally the compressor, every component has its own specific cooling requirement. So our cooling system will consist of 2 different cycles. This layout we made is based on the heat each component dissipates, as well as the recommended flow rates and pressure drops. But this is how it's going to work. Water pumped around by a set of pumps will take up heat from the different components. And afterwards the water will reach the radiator. Cool air passes through a radiator and takes the heat out of the water. The cool water can then return to the components. We added a vent to the back of the radiator to pull in more air so that we can ensure an adequate cooling at all times. We will make sure that we have adequate cooling in the car by 2 more things. 1, we will be predicting the cooling system performance by doing simulations. And also we plan to test the system thoroughly when it's finished. The experience we get from the testing can then be coupled back to optimize the cooling for each component in the car.
Guys, just explained you everything about the cooling system. And now let me introduce you to the last sub-team, mechanics. The mechanics sub-team is in charge of all the mechanical parts of the car. Last couple of months, our focus has been to research and design all these parts.
We are shifting towards a different competition and therefore a whole different car. This allows for a very different car performance in comparison to the Shell Eco Marathon. The challenge is to design the parts in a way that they will withstand all the forces that they are exposed to and make sure all parts integrate neatly with one another. Not only within our mechanics subteams, but also together with the other subteams. We will start by the base of the car, the chassis. It forms the basis as many parts are attached to it. The chassis is a so-called tubular space frame and is made of steel, which allows for enough stiffness and strength when designed by node-to-node triangulation. In this way, the chassis is able to withstand the forces coming from the suspension. Moreover, the chassis is designed in such a way the driver is safe and all components are adequately protected. The chassis consists of three main compartments. The first one is the front bulkhead, to which the impact attenuator is attached. Secondly, there is the cockpit, which is formed by two wall hoops, the front hoop and the main hoop, and the side impact structure. Next to the cockpit, there are two side pods. Behind and next to the seat, there is a firewall that protects the driver from components of the last compartment in which all of the other powertrain, electronics and cooling systems are placed. Simply said, the suspension is the part that attaches the wheels to the car. However, there is a lot to consider. The front and rear suspension are both double wishbone suspensions. Both the wheels are connected to the hub, which is again attached to the knuckle. From the knuckle, two A-arms provide the attachment to the chassis by using rod ends. The front suspension is a bit different. Here the knuckle also provides an attachment point for the steering system. Both suspensions are designed to withstand maximum cornering, accelerating and bumping. The front suspension has a lot of effect on the car performance. The braking system consists of multiple parts that all work together to enable braking. Via the pedal box and hydraulic lines, the brake pads that are incorporated in the brake calipers will move towards the brake discs. This will enable the car to brake. The brake discs are optimized in such a way that they will withstand the forces that they are exposed to and will minimally be influenced by the thermal fatigue. The steering system is designed in a way that it fits within the chassis and the suspension.
Thank you for watching this video, and thanks to all the partners for making this possible. And if you're not a partner, thank you for your interest in Green Team Twente. We hope with the switch to Formula Student and the increased attention to hydrogen that we can speed up the transition to a more sustainable future.